What if human history is not a straight line of progress, but a cycle of breakthroughs that appear, peak, and vanish? How can human footprints be found where the timeline says they should not exist? Why would a Roman glass cup shift from green to red as if engineered to manipulate light? And how could an ancient Chinese magic mirror project hidden patterns using nothing but reflection? These are not myths. They are recorded discoveries, artifacts, and traces that force scientists to slow down, recheck assumptions, and admit uncertainty. If even one of these anomalies is correctly dated and correctly understood, what else has been missing from the story of our past? Modern history is built on timelines. Layers of sediment, carbon dates, tool typologies, and written records are arranged to form a coherent narrative of human development. When new discoveries appear, they are expected to fit neatly into that structure. Most of the time, they do. But occasionally, something does not. Across different continents and unrelated cultures, researchers have encountered physical evidence that appears technically real, carefully documented, yet awkwardly placed in time. These findings do not scream fantasy. They are not legends or folklore. They are objects, markings, materials, and constructions that exist and have been measured, cataloged, and debated for decades. What makes them controversial is not their existence, but their implications. Some suggest levels of precision that seem unnecessary for survival-based societies. Others imply an understanding of materials, optics, or mechanics far more advanced than expected for their era. And a few raise uncomfortable questions about how much knowledge may have been lost rather than built upon. In response, science does what it is designed to do. Researchers search for natural explanations, erosion patterns that mimic design, coincidental alignments, misinterpretations of function, or later intrusions into older layers. In many cases, these explanations are reasonable and sometimes correct, but not always complete as such. In several instances, evidence remains suspended in uncertainty. Dating ranges overlap but do not resolve. Replication attempts fail. Context has eroded, collapsed, or vanished entirely. And without context, certainty becomes fragile. This is where popular narratives often go wrong. These discoveries are frequently exaggerated into claims of forgotten super-civilizations or impossible technologies. That approach replaces one assumption with another, equally unsupported. This investigation takes a different path. The 10 discoveries examined here are not presented as proof of hidden histories or advanced ancient worlds. Each one stands on its own as a documented anomaly, something that does not fully conform yet cannot be dismissed outright. So, together they reveal a quieter, more unsettling possibility. Human knowledge may not progress in a clean, uninterrupted ascent. It may fracture, stall, disappear, and re-emerge, leaving behind fragments that later generations struggle to interpret. What follows is not an attempt to rewrite history. It is an examination of its weak points. 1. Human footprints at White Sands, USA. In the early 20th century, researchers exploring the gypsum dunes of White Sands were not searching for controversy. Their goal was straightforward: to document signs of early human presence in what is now southern New Mexico. The environment, harsh and constantly reshaped by wind, seemed unlikely to preserve delicate evidence for long periods of time. That assumption proved incorrect. Embedded within hardened layers of ancient lakebed sediment, scientists identified a series of footprints unmistakably human in shape and proportion. Toes, arches, heel impressions, all clearly visible. Even more striking was their state of preservation. The prints were not distorted or scattered. They followed consistent paths, suggesting deliberate movement across a once wet surface. What drew immediate attention was not simply the footprints themselves, but what appeared alongside them. Running parallel to the human tracks were impressions attributed to large animals no longer present in the region. Some belonged to species believed to have gone extinct at the end of the last ice age. The spacing, depth, and orientation of the tracks suggested that both sets were formed within the same general time frame, before being rapidly buried and preserved. If interpreted at face value, the implications were difficult to ignore. Human presence in North America has long been debated, but most accepted timelines place widespread habitation far later than the extinction of many megafaunal species. These footprints appeared to compress that separation, placing humans and extinct animals within the same environmental moment. Naturally, skepticism followed. Alternative explanations were proposed. Some researchers suggested misidentification, arguing that erosion or overlapping prints could create misleading shapes. Others questioned the dating methods, noting that sediment layers can be disturbed by flooding, seismic activity, or animal movement. In a landscape as dynamic as White Sands, context is notoriously difficult to preserve. To address these concerns, teams employed multiple approaches: stratigraphic analysis, radiocarbon dating of surrounding organic material, and repeated measurements of track morphology. The results narrowed the margin of error, but did not eliminate debate. What remains unresolved is not whether the footprints exist, they do, but how confidently they can be placed within a precise historical framework. If the dating is accurate, then humans occupied this region earlier than traditionally accepted. If it is not, then the site demonstrates how easily natural processes can mimic meaningful patterns. Either conclusion is significant. White Sands does not provide a definitive answer. Instead, it highlights a recurring problem in archaeology. When evidence survives but context erodes, interpretation becomes provisional. The footprints stand as a quiet challenge, not to rewrite history, but to acknowledge that parts of it remain incomplete. 2. Microlithic tools at Bhimbetka, India. In the early 1960s, archaeologists surveying the rock shelters of Bhimbetka in central India expected to find familiar signs of prehistoric life: stone flakes, simple tools, and evidence of long-term habitation. The region was already known for its extensive cave paintings and stratified occupation layers spanning thousands of years. What they did not expect was scale, specifically how small it could be. Scattered across the cave floors were microlithic tools so tiny that many were initially overlooked. Upon closer inspection, these objects revealed an extraordinary level of craftsmanship. Each piece had been deliberately shaped, with sharply defined edges, precise notches, and consistent geometries. Some were no larger than a fingernail, yet showed symmetry and intentional design. The technical challenge was immediately apparent. Working stone at such a minute scale requires exceptional control. A single miscalculated strike would shatter the entire piece. Yet dozens, sometimes hundreds of these microliths were found intact, suggesting that their creators were not experimenting blindly, but operating within a refined and repeatable technique. Even more puzzling was their arrangement. Several tools appeared clustered or stored in patterns, as though deliberately set aside rather than discarded. This implied planning, foresight, and an understanding of future use, concepts often associated with much later technological stages. Attempts to replicate these tools in modern experimental archaeology have highlighted the difficulty. Even with contemporary knowledge of stone fracture mechanics, reproductions frequently fail. The margin for error is minimal, and success requires sustained precision over repeated actions. This raises a fundamental question. How did humans living thousands of years ago, without metal tools or magnification, achieve such consistency at a microscopic level? Survival alone does not demand this degree of refinement. The tools suggest specialization, possibly for composite weapons, fine cutting tasks, or purposes no longer visible in the archaeological record. Skeptics argue that microliths represent efficiency rather than sophistication. Smaller tools require less material and can be easily replaced. This explanation is plausible but incomplete. Efficiency does not account for the uniformity, the repeated success, or the apparent intentional storage. As with many discoveries in archaeology, the objects themselves are not disputed. Their interpretation is: Bhimbetka's microliths do not prove lost technologies or forgotten civilizations. What they demonstrate is something quieter but equally important, that early humans were capable of precision far beyond what simplistic models of prehistory often assume. They remind us that technological ability does not always leave behind large monuments or obvious machines. Sometimes it survives only in fragments so small that history almost misses them. 3. Optical lenses and glass technology in the Roman Empire. For centuries, glass artifacts from the Roman world were classified as decorative. Cups, beads, and vessels valued for color and form rather than function. This assumption began to shift when archaeologists and historians identified a subset of Roman glass objects shaped with deliberate curvature. These were not ornamental accidents. Several artifacts, often made from clear or lightly tinted glass, displayed consistent convex or concave forms capable of magnifying text or small objects. When tested under controlled conditions, some produced measurable optical enlargement. The surfaces were smoothed and polished, indicating intentional shaping rather than incidental wear. The implications were subtle but significant. Creating a functional lens requires more than molten glass. It demands controlled cooling, precise shaping, and careful polishing to reduce distortion. Even minor imperfections can render a lens ineffective. Yet these Roman examples demonstrate repeatable curvature and clarity sufficient for magnification. What remains unclear is their intended use. One possibility is practical craftsmanship. Roman artisans worked extensively with fine engraving, gem cutting, and miniature detail. Magnification would have been a powerful aid. Another hypothesis involves medical applications, such as examining wounds or assisting aging eyesight. A more speculative suggestion points toward early observational tools, though no direct evidence confirms astronomical or scientific deployment. Skeptics caution against overinterpretation. They argue that some glass shapes may be coincidental byproducts of manufacturing or repurposed objects later mistaken for lenses. In isolation, this explanation is reasonable. However, the recurring appearance of similarly curved pieces across different sites complicates that dismissal. Equally notable is what does not survive. If lenses were used as part of larger optical systems, frames, mounts, or assemblies, those components may have been made from organic materials that decayed over time. What remains are isolated elements, stripped of context. This absence creates a familiar archaeological problem. Without accompanying tools or written explanations, it becomes difficult to assess how widespread or sophisticated Roman optical knowledge truly was. The lenses neither confirm advanced science nor fit comfortably into a narrative of purely decorative glasswork. Instead, they occupy a narrow space between sound. They suggest that Roman craftsmen understood, at least intuitively, how curvature and transparency could manipulate light. Whether this knowledge was systematically applied or remained limited to niche practices is unknown. As with many discoveries examined here, the question is not whether the Romans possessed modern science. It is whether fragments of practical knowledge once existed and were later forgotten because they left too little behind. 4. The magic mirrors of ancient China. Among the bronze artifacts of ancient China, a small group of mirrors has long puzzled scholars. At first glance, they appear ordinary, polished metal discs with decorative patterns engraved on the reverse side. Their reflective faces are smooth, unmarked, and seemingly plain. Their true anomaly only appears under light. When sunlight is reflected from the mirror onto a wall, an unexpected image emerges. The pattern carved on the back of the mirror, often invisible from the front, appears projected in light. Lines, symbols, and inscriptions materialize as if the mirror were transparent, despite being made of solid bronze. This phenomenon earned them a modern name, magic mirrors. The effect is not illusion or trickery, it is physical. Detailed studies suggest that the mirrors were cast and polished with extraordinary precision. Subtle variations in thickness and microscopic differences in surface curvature cause light to reflect unevenly. When the reflected rays converge on a surface, they reproduce the hidden pattern with remarkable clarity. The challenge lies in control. These variations are so slight that they are almost impossible to detect without modern instruments. Achieving them intentionally would require careful planning during casting and meticulous polishing afterward. Too much pressure or an uneven surface would erase the effect entirely. Yet multiple examples exist. Magic mirrors have been dated to different periods and regions, indicating that the technique was not an isolated experiment. It was known, practiced, and repeated, suggesting a level of material understanding that extended beyond simple craftsmanship. Skeptical interpretations propose accidental outcomes. According to this view, the effect emerged unintentionally during casting, later noticed and preserved because it appeared unusual. While possible, this explanation struggles to account for the consistency across surviving specimens. Accidents rarely reproduce the same optical behavior again and again. What remains unclear is the purpose. There is no surviving text explaining how these mirrors were made or why the effect mattered. They may have held ritual significance, symbolizing hidden truth revealed by light. They may have been demonstrations of skill or objects designed to impress patrons with effects that bordered on the supernatural. Whatever their function, the mirrors demonstrate a crucial point. Ancient craftsmen were capable of manipulating light without mathematical optics, equations, or modern theory. They worked empirically, through observation, repetition, and refined technique, arriving at results that still challenge explanation. The magic mirrors do not imply lost science, they imply lost processes. Knowledge that was once practical, embodied in hands and habits, rather than preserved in writing, making it far easier to disappear. 5. The Lycurgus cup and Roman color-changing glass. Stored for centuries without attracting special attention, the Lycurgus cup was long considered a finely carved example of late Roman glassware. Its surface depicted a dramatic scene from mythology, rendered with exceptional detail. At first glance, it appeared to be nothing more than an artistic luxury object. That assessment changed when light was introduced. When illuminated from the front, the cup appears green. When light passes through it from behind, the same glass shifts to a deep red. The color change is not painted, stained, or applied as a surface treatment. It occurs within the material itself. Modern analysis revealed why. Embedded in the glass are microscopic particles of gold and silver, dispersed so finely that they interact with light at the nanoscale. Depending on how light strikes the cup, different wavelengths are absorbed or scattered, producing the dramatic color shift. This discovery placed the Lycurgus cup in an unexpected category. The physical principle behind its effect is well understood today, but only after the development of modern material science and nanotechnology. Roman artisans had no microscopes, no theoretical framework for light behavior at this scale, and no recorded explanations of how such an effect could be engineered. Yet the object exists. The immediate question is whether this outcome was intentional. Some researchers suggest the effect may have been discovered accidentally during glassmaking, then refined through trial and error. Others argue that the precision of the particle distribution indicates deliberate control, not chance. Neither position can be conclusively proven. What is clear is that reproducing the effect requires careful balance. Too many particles or uneven dispersion, and the glass becomes opaque. Too few, and the color shift disappears. The Lycurgus cup achieves a narrow and stable equilibrium. Equally important is what the cup represents in context. It is not a prototype or an unfinished experiment. It is a completed decorative object, suggesting that the technique, whatever its origin, was reliable enough to be used in elite craftsmanship. This raises the possibility that similar knowledge existed more broadly, even if few examples survived. The Lycurgus cup does not demonstrate advanced science in the modern sense. It demonstrates advanced outcomes achieved without modern explanations. It stands at the boundary between art and engineering, where empirical knowledge produced results that later generations would struggle to interpret. And like many artifacts examined here, it poses a restrained but persistent question. If such material control was possible once, why did it not continue? 6. Dichroic and iridescent glass in the Roman Byzantine world. The Lycurgus cup is often presented as a singular anomaly, a rare accident of ancient craftsmanship. However, when examined within a broader archaeological context, it appears less isolated than once believed. Across the late Roman and early Byzantine periods, a number of glass artifacts display unusual optical behaviors. Some shift color depending on viewing angle. Others produce shimmering, iridescent surfaces that change under different lighting conditions. These effects are embedded within the glass itself, not applied as paint or surface decoration. This suggests a pattern, not a coincidence. Chemical analysis of several surviving examples indicates controlled manipulation of metal oxides and trace elements during glass production. The results vary, some subtle, others striking, but the underlying principle is consistent. Light behaves differently when interacting with materials structured at extremely fine scales. The challenge lies in repeatability. Glassmaking is inherently unstable. Temperature, composition, cooling rate, and contamination all affect the final product. Achieving consistent optical effects would require not only experimentation, but an accumulated understanding passed between craftsmen. Such knowledge would likely exist as practice rather than theory, learned by doing, corrected by failure. Written documentation, however, is almost entirely absent. No surviving manuals describe how these optical effects were created. No treatises outline formulas or methods. What remains are finished objects, divorced from the processes that produce them. This absence complicates interpretation. Some scholars argue that these effects were incidental byproducts of decorative glassmaking. Over time, artisans may have noticed unusual visual results and replicated them without fully understanding the cause. This explanation accounts for variability but not intentionality. Others point to the consistency across regions and time periods as evidence of a shared technical tradition, one that valued visual transformation and controlled light as part of elite material culture. Neither view can be confirmed with certainty. What can be stated is this: the Roman-Byzantine glass tradition demonstrates that ancient craftsmen were not merely shaping form and color, but interacting with physical properties of materials in complex ways. They produced results that modern observers often interpret through the lens of advanced science, even though the original knowledge may have been entirely empirical. This creates a familiar pattern. When technical expertise is embedded in practice rather than recorded in text, it becomes vulnerable. Disruption, economic collapse, political change, or loss of skilled labor can erase generations of accumulated understanding. The dichroic and iridescent glasses of the Roman-Byzantine world are not proof of forgotten technology. They are evidence of fragile knowledge, effective, repeatable, and yet ultimately perishable. They remind us that what survives from the past is not always what was most sophisticated, but what was easiest to preserve. 7. The Portland vase and the limits of Roman glass control. Among surviving Roman glass artifacts, few have attracted as much scrutiny as the Portland vase. At first glance, it appears modest in size, a dark blue vessel adorned with pale, raised figures. Closer examination reveals why it has remained a subject of debate for centuries. The vase is made using a technique known today as cameo glass. This process involves layering two different colors of molten glass, allowing them to fuse and then carefully cutting away the outer layer to expose the contrasting inner surface. The result is a sculptural relief carved not in stone but in glass, a material that offers no tolerance for error. The technical difficulty is extreme. Glass does not behave like marble or metal. Internal stresses form as it cools. Uneven pressure, excessive heat, or a misjudged cut can cause fractures that destroy the entire object. Despite these risks, the Portland vase displays clean edges, consistent depth, and finely controlled transitions between layers. This level of precision implies more than artistic ambition. To succeed, craftsmen would have needed intimate knowledge of glass behavior, how it responds to temperature changes, how stress propagates through layers, and how much material can be removed without failure. Such understanding is rarely achieved through chance alone. Attempts at replication underscore the challenge. Modern glassmakers, equipped with advanced tools and temperature control, have reproduced cameo glass only with difficulty. Even with contemporary techniques, failure rates remain high. That Roman artisans achieved similar results without modern instrumentation raises unavoidable questions about their methods. Yet context is again missing. There are no surviving records describing the process, no workshop notes, no lineage of instruction. The knowledge appears to have existed, functioned effectively, and then disappeared. By the medieval period, cameo glass of comparable complexity was no longer being produced. Some historians suggest the Portland vase was an exceptional commission, an outlier made by a singular master. Others argue it represents the upper limit of a broader but fragile tradition. With so few surviving examples, distinguishing between these possibilities is impossible. What can be said with confidence is this: the Portland vase demonstrates a level of material control that borders on the mechanical, achieved through manual skill alone. It shows that Roman glassmaking was not confined to decorative surfaces, but extended into three-dimensional precision work at the edge of material failure. Like the Lycurgus cup, it occupies an uncomfortable space in historical narratives. It is neither primitive nor easily categorized as advanced technology. It is evidence of expertise that flourished briefly, left little trace, and then vanished. Not because it was impossible to continue, but because the conditions that sustained it did not endure. 8. Megalithic precision at Pumapunku, Bolivia. High on the Bolivian plateau, near the ruins of Tiwanaku, lies Pumapunku, a site that challenges expectations not through mystery alone, but through precision. Unlike many ancient monuments defined by weathered stone and irregular forms, Pumapunku presents something different: geometry. The site is composed of massive stone blocks, some weighing over 100 tons, arranged with striking regularity. Flat surfaces meet at sharp angles. Grooves, channels, and right angles appear repeatedly, often mirrored across separate stones. In several cases, blocks interlock so closely that even thin blades cannot be inserted between them. The question is not whether these stones were shaped intentionally. They were. What complicates interpretation is how such precision was achieved. The stones are primarily andesite and sandstone, materials known for their hardness. Carving them to such flatness and uniformity would require sustained abrasion, controlled force, and consistent measurement. Modern analysis shows that many surfaces vary by only fractions of a millimeter. Equally puzzling is scale. Precision at small size is demanding. Precision at monumental scale compounds difficulty. Errors that are trivial in a small object become catastrophic when multiplied across tons of material. Yet at Pumapunku, repeated elements maintain consistent dimensions, suggesting standardized planning rather than improvisation. Transport adds another layer of uncertainty. The nearest known quarries lie kilometers away. Moving stones of this mass across uneven terrain without wheeled vehicles, metal tools, or draft animals poses logistical challenges that remain debated. Hypotheses include sledges, rollers, water lubrication, and coordinated human labor. None fully account for the combination of distance, weight, and precision observed. Skeptical interpretations emphasize erosion and reconstruction. Some researchers argue that perceived precision has been exaggerated, or that later restoration altered original alignments. These cautions are valid. However, even accounting for damage and reconstruction, measurable regularities persist. Context, once again, is incomplete. No detailed records describe the builder's tools, methods, or organizational systems. The culture associated with Pumapunku declined, and whatever technical knowledge sustained the site did not continue in a clearly traceable form. Pumapunku does not require advanced machinery to be impressive. It requires something more elusive: sustained accuracy, repeatability, and coordination over time. In this sense, the site aligns with a recurring theme. Whether working at the nanoscale of glass or the megastructure of stone, ancient builders occasionally achieved results that strain modern assumptions, not because they possessed unknown technologies, but because they applied known materials with uncommon discipline and skill. What remains unanswered is how such practices emerged, how long they persisted, and why they disappeared. 9. Carvings of flying machines in the Peruvian desert. In the arid regions of southern Peru, a collection of carved stones has generated sustained controversy for decades. These artifacts, commonly associated with the area around Ica, depict scenes that differ sharply from typical ancient iconography. Instead of animals, rituals, or daily life, many stones show human figures interacting with mechanical forms. Some carvings appear to represent gliders, winged craft, or enclosed machines resembling aircraft. Figures are shown seated or positioned within these forms, hands placed on what resemble controls or levers. In several cases, the compositions suggest balance, propulsion, and directional movement rather than symbolic abstraction. The volume of material is part of the puzzle. The stones number in the hundreds, displaying variations on similar themes. This repetition suggests a shared visual language rather than isolated artistic invention. If the images were purely decorative or mythical, their mechanical consistency is unusual. Interpretation, however, is deeply divided. Skeptics argue that the stones are modern fabrications, created to attract attention or profit. Others suggest that even if ancient, the carvings may represent symbolic or cosmological imagery, visions of flight associated with gods, spirits, or shamanic experiences rather than physical machines. These explanations are plausible and in many cases supported by circumstantial evidence. Yet unresolved issues remain. Certain carvings include details that appear functional rather than symbolic, structured wings, enclosed frames, and body positions consistent with piloting rather than worship. While none of this proves technological flight, it complicates a purely mythological reading. Context is again the limiting factor. Many stones were discovered outside controlled archaeological excavations, stripped of stratigraphic data that could clarify their age and purpose. Without reliable context, definitive conclusions remain impossible. This uncertainty places the Peruvian carvings in a familiar category. They cannot be confidently accepted as evidence of ancient aviation. They also cannot be fully dismissed without ignoring their internal consistency and recurring motifs. As images, they challenge assumptions about what ancient artists chose to depict. As artifacts, they highlight how easily meaning collapses when provenance is lost. Whether misunderstood symbolism, later alteration, or something else entirely, the carvings force a restrained but necessary question. When imagery does not match expectation, is the error in the artifact or in the framework used to interpret it? 10. Greek fire and the lost chemical knowledge of the Byzantine Empire. In the early medieval world, few weapons inspired as much fear as Greek fire. Described in multiple historical sources, it was a combustible substance used primarily in naval warfare, capable of burning with extraordinary intensity and resisting conventional methods of extinguishing. What made Greek fire remarkable was not only its destructive power, but its exclusivity. The formula was treated as a state secret, guarded at the highest levels of the Byzantine administration. Production was centralized, access was restricted, and written records were either deliberately obscured or never created. As a result, Greek fire functioned less like a weapon and more like a controlled technology. Accounts of its effects are consistent. Contemporary writers describe flames that clung to surfaces, ignited on contact, and spread rapidly across enemy ships. Water appeared ineffective. Panic, rather than physical damage alone, often decided battles. Greek fire gave the Byzantines a strategic advantage disproportionate to their military size. Yet despite its prominence, the substance vanished. By the later medieval period, Greek fire was no longer in use. No reliable recipe survived. No laboratory notes, no technical manuals, no clear descriptions of its chemical composition remain. Modern attempts to recreate it rely on conjecture, combining substances such as petroleum, resins, sulfur, and quicklime, but none can be confirmed as authentic. This disappearance is significant. Unlike many ancient technologies lost to prehistory, Greek fire existed within a literate, bureaucratic society that maintained archives and legal systems. Its loss cannot be attributed solely to the absence of writing. Instead, it illustrates a different vulnerability. When knowledge is concentrated, restricted, and not widely transmitted, it becomes fragile. Several explanations have been proposed. Political upheaval may have disrupted production. Skilled specialists may have died without passing on their expertise. Economic changes may have rendered the technology impractical. Any or all of these could apply. What matters is the outcome. A functioning technology ceased to exist, leaving only descriptions of its effects. Greek fire does not suggest forgotten science beyond human capability. It demonstrates something more plausible and more unsettling. Advanced practical knowledge can disappear, even in societies that appear stable and sophisticated. When that happens, future generations are left with artifacts, stories, and unanswered questions. In this sense, Greek fire serves as a fitting conclusion to the pattern seen throughout these discoveries. Not every mystery points to something extraordinary. Some point to something ordinary but rare, the loss of know-how. And once lost, it may never return. When history refuses to stay simple. 10 discoveries. 10 cases that, on the surface, appear to challenge how history is usually told. Human footprints that seem misplaced in time. Tools too small to be casually dismissed. Glass that manipulates light in ways science only recently explained. Stonework executed with precision that strains assumptions about ancient capability. And technologies that once worked, then vanished without a trace. None of these discoveries, taken alone, is enough to overturn established history. There is no single artifact here that proves lost super civilizations, impossible machines, or forgotten sciences beyond human reach. That is not the point. What these cases reveal is something more restrained and more troubling. History is not a complete record. It is a reconstruction, assembled from fragments that survived erosion, collapse, neglect, and chance. What we call the past is shaped not only by what remains, but by what did not endure. In several instances, science offers plausible explanations. Natural processes can mimic design. Artifacts can be misinterpreted without context. Technologies can appear more advanced when separated from their everyday use. In other cases, the evidence is simply incomplete. Dating ranges overlap. Provenance is lost. Documentation ends. And when context disappears, certainty becomes impossible. This does not weaken science, it defines it. Scientific understanding advances not by defending comfortable narratives, but by confronting anomalies honestly, acknowledging uncertainty, refining methods, and resisting the temptation to replace one assumption with another. The danger lies not in asking difficult questions. It lies in answering them too quickly. Together, these 10 discoveries do not demand belief, they demand humility. They remind us that human knowledge does not move in a smooth, uninterrupted ascent. It can stall, fragment, and vanish, sometimes quietly, sometimes completely. Skills can exist without theory. Techniques can function without explanation. And when the conditions that sustain them disappear, so can the knowledge itself. If future generations were to examine our own civilization through scattered remains, without manuals, servers, or living experts, how much of what we know would still make sense? That question may be the most unsettling discovery of all.